Hi, welcome. I'm Dr. Christine Jurazinski. I'm a staff scientist at Cognitive Learning Systems, and I wanted to talk to you today about the next generation science standards. These standards are set to come out in spring 2013, the final draft. And one of the things I found through years of talking with teachers, doing teacher professional development, is that every time a new set of standards comes out, there's always some apprehension about them. So I'd like to walk you through these next generation science standards today so that we can take a look together what they look like, what the details are. You'll see that they truly are simple. And as we walk through them, you'll really be able to think of some ideas and some ways to help your students begin to think scientifically and to develop resources for yourself. Welcome! Our topic today will focus on understanding the next generation science standards. But before we can begin discussing the next generation science standards, we need to understand the content on which they focus, and that is science. Let's begin by asking, what is science? Why? Because only by asking ourselves this question can we understand what it is that we want our students to know and be able to do with science. So what is science? Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. You'll notice the word testable here. This means that science is an active process of experimentation. Knowledge in science is gained by a gradual synthesis of information from different experiments by various researchers across different domains of science. It's more like a climb than a leap. In other words, it's a continual process. And this is something when we teach science, we need to project to our students. Science is not just one experiment or one project. Every experiment builds on what was previously learned and will become a building block for the next question or experiment. Science involves experimentation, and this experimentation is especially important in science to help establish causational relationships and to avoid correlation fallacy. Perhaps this is the most important bullet on this slide. Science is experimentation. Science is not the same as critical thinking. It uses critical thinking, but it is more than that. It involves experimentation as well as the synthesis of information, the synthesis of specific scientific information.